Okay, so now this is video 6. This is the second part of hearing. In this video, we're going to review the structures of the ear. We're going to talk about theories on hearing, and we're going to talk about 2 different types of deafness. So let's review your parts of the ear. You received a handout in class. It was yellow. Okay, so the first part we talked about in the last video was the pinna. Okay, this is part of the outer ear, along with the auditory canal and the eardrum, otherwise known as the tympanic membrane. You then have the middle ear, which is the hammer, anvil, and stirrup. Okay, and then you have the inner ear, which is the oval window, the cochlea, the basilar membrane, and the auditory nerve. Semicircular canals, again, were not so much part of the ear for hearing. It more helps with movement and balance. So let's talk about the different theories. The first theory we're going to look at is place theory. Place theory is defined to help us understand the difference between high-pitched sounds and low-pitched sounds. It's a theory that links the pitch we hear with the place in the cochlea where it's stimulated. Okay, so what they believe with place theory is there's different areas in the cochlea that are impacted that help us understand what the pitch is. So if it hits towards the front portion of the cochlea, that helps us understand high-pitched sounds. Back is low-pitched sounds. So here we are. Higher-pitched sounds, higher frequencies, okay, are usually found by the oval window in the blue area. Lower-pitched sounds are found curled up in the specific back end of the membrane, which is the red area. What they believe is different frequencies of sound are said to vibrate at different places in the cochlea. These places are wired to different parts of the auditory cortex in the brain and can be processed correctly. One thing I'm going to add on here, okay, which this theory helps us understand, is it helps us understand high-pitched sounds. So make sure you add that in. And what this means is they really feel that this theory defines high-pitched sounds because depending on where it hits, it helps us understand a sound, right? Well, over time, as we get older, we begin to lose these little hairs. So why Miss Gavin can't specifically hear high-pitched sound is because I lost those hairs in the cochlea. So this theory really helps us understand high-pitched sounds. We have frequency theory. Frequency theory is used to explain the pitch of the sound as well. Specifically, a lot of low-pitch sounds helps us understand this pitch. Waves vibrate at different rates. Okay, so these are going to vibrate a lot faster than these waves. Okay, creating different impulses that are sent to the brain. Pitch then is determined how fast these are vibrating versus how fast these are vibrating, which sends signals up to the brain. The faster the vibrations, the higher the pitch. The slower the vibrations, the lower the pitch. Okay? Make sure you have these 2 things drawn in your notes as well. Sound localization. So the auditory system's ability to locate where sounds are coming from. So where is the sound coming from? Is it coming from the right or the left? If a sound originates closer to your left ear, the sound will reach your left ear sooner, and so you'll be able to tell that it comes from the left side. However, what if it comes from directly, it's even on both sides of your head? It's hard to identify then where the sound is coming from. So what happens if you can enter each side at the same time? So sound comes here at the same time as a sound coming here because the sound is right in the middle of your ability to hear. One struggles then to locate which sound because it's coming from equidistance from each section of the ear. Okay, so there's 2 different types of deafness. You could have conductive deafness or sensory neural hearing loss. Conductive deafness is in the inability to hear resulting from damage of the middle ear and outer ear. So something may have happened here in the tympanic membrane, or maybe happened because of the 3 bones got damaged. Okay, a lot of this is fixed by hearing aids, right? You're born with the ability to hear, and then over time, something may have happened to damage these. Sensory neural hearing loss is the inability to hear linked to a deficit in the body's ability to transmit impulses from the cochlea to the brain. So there's something wrong here with the nerves. You're a lot of times born this way. Maybe you're born without hairs in the cochlea. So messages can't be sent to the brain. because the sound waves don't transmit to messages. A lot of the times they're given cochlear implants, a device to convert sounds into electric impulses by stimulating the nerve by the sound waves in the environment. Kind of a cool different slide you can freeze and look at. It talks about the cochlear implants. We will talk about this more in class, but it kind of walks you through how cochlear implants work inside the ear. You don't need to know specifically how it works inside the ear, but you do need to know that sensory neural connects to cochlear implants.